My name is Naila, and with me here is my colleague Wenxue. Both of us, we work in the Raster team. We are software developers, and we are responsible for extending image services support in our WebGIS products. So let's see what we're going to talk about today. The aim of today's session is for you guys to create smart and powerful applications where imagery is not just a backdrop, but it's more used for analysis and to make decisions in your day-to-day world. So JavaScript API will definitely be the biggest portion in today's session, but we would also like to talk about the things that we've added in ArcGIS Online and portal for ArcGIS, and we'll touch a little bit on Web AppBuilder as well. So moving on to image services, I just want to have an idea about, how much of you have actually worked with image services and with probably working with ArcGIS Online. Okay, great. So I don't need to probably spend a lot of time in telling you guys about image services and the history and what they can do. But in short, image services, they provide us fast access to raster data through a web service. What it means is that if you have a raster data, and they can be of different formats, it could either be just a single image or you could have multiple images. You can publish that through our ArcGIS server. And once it's published as an image service, any of the devices that support a web service can now talk to this image service. It can display it, it can query, it can, you can visualize it, you can analyze it, you can process the imagery now. So like I mentioned, that image services are no longer being used as just a backdrop. Definitely they are. I mean, we still have base maps and other things. But more and more we've noticed that users want to do analysis. They want to process their imagery. They want to make decisions. And that's how you do it. I mean, basically, when you have your raster data, you can publish it just as is and use it for visualization. But you can also attach processing with it. And you can let your users use this processing to make decisions. When it's just a single raster, then you can query for pixel values. But when you have multiple rasters and when you publish that as an image service, you can even query for individual rasters, get more information about the metadata, about the attributes, when the image was taken, what was the cloud cover. And there could be so many other things that you can have in your backend database. So when it comes to processing, and when you publish your data with the processing, as clients, you can tell your server to run the process on the server side and give the results back. As we move forward in the presentation, we'll also show you how on the client side you can actually do processing without even querying or asking server to do the processing. So I'm going to quickly switch over to ArcGIS Online Map Viewer and just show you some basic capabilities that we have for image services. Over here, I have this Charlotte elevation data, which looks horrible on the projection, sorry. It doesn't look that dark over here, but for some reason, the colors are not coming up correct. But the idea is that once you add an image service, you can either search for it, and you can search in your content, you can search in your organization, or you can just add an image service layer. But once you've added, you'll see that the generic controls that we have, like the legend, the attribute table, you can set filters, but we also have some more imagery-specific options that are available, like the image display. Image display is really useful when you publish your raster data along with some processing. So as I was mentioning earlier, this image service was published with these 3 different processing. And as a user, I can just pick one and apply and see the changes on my map. So it's that simple. In addition to that, you can also apply stretch. You can stretch your imagery. And the new thing that we added in 10.5 is actually the ability to define a color ramp. So we have these well-defined color ramps, and you can pick any one of them and apply it on the fly. Going back, the other thing I wanted to show was the image display order, where you can actually define how the multiple rasters in a certain area are mosaicked together. So we have these different methods where you can say, okay, based on an attribute, I would like an imagery which satisfies this attribute to be the topmost image, or you could say that, okay, the image where the center is closest to my view center should be the topmost image. But basically, we have these methods where you can define how the images, multiple images in a certain location can be mosaiced together and returned back to the client. The other functionality I want to highlight over here is pop-ups. Now, pop-ups are available for all these different types of layers. But what's special for image service layers are some of the pixel type fields. And as I move down, let me just turn on a couple of them. As I scroll down, I can see that I have these different types of pixel type fields. And they also, these special fields for image services, they all start with raster dot. What it means is the service pixel value is actually the pixel value after your images are mosaiced together. So as a client, you can request for the mosaiced pixel value. The raw pixel value is pretty handy when you're applying a processing on your image service. So just like previously when I selected shaded relief, if I wanted to get the shaded relief value, I would actually be looking at the service pixel value, but the raw pixel value is before the shaded relief was applied. So I'm going to turn these on so that you guys can have a look. The item pixel value is the pixel value of each image that was being used for mosaicing. So you can query each individual image at that location and ask for its pixel value. And the other three ones that we have over here are kind of dynamic fields, and they depend on what processing is attached with your image service. So like how we saw previously, this image service had those three different type of processing templates, the aspect, hill shade, and shaded relief. And if I turn them on, you can see that even though I might be looking at shaded relief, but I can actually query for a hill shade value or an aspect value. So now if we query for our pop-ups, we can see the different values for that location. So what it's doing is it's actually for that location, it's running those pixels through the processing and giving back the results to the client. Now let's go back and take a look at some of the things that we've added in ArcGIS Enterprise 10.5. One of the biggest features that you guys must have heard about, raster analysis, there were a lot of talks about it, it was there in the plenary also, is raster analysis. Raster analysis lets you extract or quickly extract information by executing not only raster models, but also spatial models. And it leverages your distributed storage and analytics. The cool part is that you don't need to actually upload all your data to make it work with raster analysis. You can have your services published on your server. You can just access those services as input for your analysis, and it'll just work. When you run analysis, the output is actually in a specialized distributed storage format, which is known as CRF, Cloud Raster Format. And this format is highly optimized for raster analytics computations. It supports multiple reads and writes. And this story is not only for users. Like today, we'll touch base a little bit on how you can actually perform analysis using MapViewer. But if you are a developer, you can actually, we have a full REST API where you can use that. You can write your own scripts and run analysis using those scripts. So it's pretty simple to get raster analysis set up. All you need is to run it comes out of the box, and you just need to run your setups, which is for your server, for your portal, for your data store, and your web adapter. You can have server installed on multiple nodes, and once you're done installing, you can set up which server can be used for raster analysis. We recommend that you have a dedicated server used for raster analysis. You can also configure your raster data store where all your output formats, the outputs of running analysis will go in, and you're just ready, that's all you need to do to actually use it. I'm going to give a demo and quickly show you the tools that we have in MapViewer, which is one of the clients for raster analysis. But the good part is that once the whole system is pretty integrated. You have your inputs, which are published as services on your server. You use that as input. You create output, which again goes back as services on your server. And you can just use those services in wherever you want. Story maps for creating web maps, for using it in Web AppBuilder. But the whole system is pretty integrated. And let's take a look at what we have in Portal for ArcGIS for raster analysis. So again, I have the same Charlotte service, which looks horrible on the screen. And when I click on analysis, since I have ArcGIS Enterprise 10.5, I would see these two options. And I know that I've set up my server to perform raster analysis, so I would see the raster analysis option. And when I click on it, I see these different tool sets which have been defined in these special categories. And I can use any of these tools now. Each of these tools have a pop-up help, which tells you more about what the tool does. Each input also has a pretty detailed help to give you more information on how the inputs are specified. In this case, I just want to run slope. So I go to Analyze Terrain, and I click on my slope tool. And the most important part is when you run analysis, this analysis is not run on the display resolution. It's run on the source resolution. And the output is a persisted output, which is very different from what we did earlier, where you had processing published with your service, and as client, you chose, OK, I want to see the shaded relief. But that was all dynamic. It was done on the display resolution. This is a persisted product, and it's run on the source resolution. I can specify my output service name. I can define which folder it should go to, hit analysis, and now it's sent a job to the server to run and process my imagery. So it's that simple. Now, the other important feature that we added for ArcGIS Enterprise is an image collection. An image collection is actually a portable file, or it's just a zip file, which can contain one or multiple rasters. Now, let's say in your organization, you have your manager or your boss coming up saying that I have this pretty cool elevation application which lets me do dynamic hill shading. And I have these 10 elevation files. How do I use it? So you have a couple of options. You can either go figure out if you have a desktop product, go there, publish these files as a service, and then use it in your application. Or the faster, the quicker way to do it now at 10.5 is that you can go to your My Contents. You can just zip these files as a zip file, upload them, publish them as a hosted image service, and then just use it in your application. So to show you how simple it is, I'm here in My Content in Portal for ArcGIS. And I click Add Item, and now I can just choose my zip file. And once I choose it, the important part over here is to define the right item type. It's an image collection because I have my rasters in a zip file. And I can define the tags, hit Add Item, and then I'll be done. When it's uploaded, you would see that you would see two items. One is your image collection, which is your zip file, and you can actually download that. The other one is your hosted image service. And this image service is just like a regular image service. You can add it to a map, and you can work with it like any other image service. So it's just a quick way of uploading a small set of files and making it available so that you can use it in story maps or in your custom applications. And just like before, I can define my stretch, I can define my color ramp, and I can use it in my web map and save it as part of my web map. And then I can use it in Web AppBuilder or any other application I want to use it. So this is pretty cool. What do you guys think? Yeah? OK, no? Yes? OK. So moving on. This is the demo that we saw. Now we'll talk about ArcGIS API for JavaScript. And I will hand it over to Wenxue.
Right, thanks, Naila. Now let's get into the coding part. We'll go through the ArcGIS API for JavaScript. There's classes, methods that are related to image services. There are roughly 4 different types of layers in JS API that you can use today to work with image services. These 4 different layers are there in 3x. For 4x, we actually only have 1 layer today, which is the Imagery layer. So we'll discuss that part later. So ArcGIS image service layer is the first layer we introduce in JS API that can leverage all the capabilities of image server to perform server-side processing, dynamic mosaicking, etc. And one good thing about this ArcGIS image service layer is it supports the legacy browsers, such as IE8 that came with Windows 7, which, well, nowadays still a lot of people using it. So ArcGIS tiled map service layer is the layer that we can use to work with the tiled image services. It is the same layer that we use to work with the tiled map services, because once it's cached JPEGs, PNGs, there's really no difference which type of endpoint you use. So Raster Layer is a layer we introduced about 2 years ago. It's designed to replace ArcGIS image service layer. It's completely redesigned to leverage the HTML5 technology. So the benefit that comes with it is we can not only perform server-side processing, leverage the features offered by image server, we can also perform some client-side processing and filtering and rendering, etc. Because it's really leveraging the canvas element in HTML5. So there is a cost comes with that. Of course, is it can only be run modern browsers. For IE, we actually require IE11 because IE11 gives you capability to mess with pixels on canvas using the int8 clamped array. So the last layer we have in JS API is ArcGIS image service vector layer. It's a special layer that's designed to work with 2-band scientific data that's usually represent wind force or ocean current, this kind of vector field data. So the constructors for these layers are very similar, just like any other ArcGIS image service ArcGIS layers in JS API. You provide the URL and the optional parameters. One such optional parameter is called image service parameters. Right here, we actually specify how we want the server to deliver the image to us. It's actually closely related to the REST API export image operation, where you can specify the format, the number of bands, the band IDs, interpolation method, compression quality, etc. And 2 important ones, which we'll cover in the follow-up demos, are mosaic rule and the rendering rule. 2 methods you instruct the server to perform dynamic mosaicking and on-the-fly processing. So the layers has a lot of different methods and capabilities. Certain capabilities and methods are only available to mosaic dataset, such as dynamic mosaicking and query visible rasters. You have to have a collection of images to use these APIs. Under the multidimensional API, the dataset itself has to be multidimensional data. These are usually came from netcdf, HDF, or GRIP files. So the server-side processing and the mosaicking are achieved through 2 different classes. For processing, it's achieved through Raster functions. For mosaicking, it's achieved through mosaic rule. So for Raster function, essentially we create a Raster function object. We give the name of the Raster function. The name of the Raster function is documented in ArcGIS REST API. There are a lot of different Raster functions we can use. Essentially, these are well-implemented algorithms on server that are available to JavaScript developers. We just give the name of the processing algorithms, which is the function name. We pass down all the required parameters. Then we call the Raster layer to set the rendering rule. Essentially, we define this processing algorithm and the parameters let the server to process. So the mosaic rule is similar. We define what type of mosaic method we want to use. Do we want to sort the image by a particular order, or do we want to lock the display to a particular raster in the big collection? Then we set the mosaic rule on the layer. So I took a snapshot from ArcGIS Pro there are a lot of different Raster functions available today, close to roughly like 100 or so. So most of them, those with red check marks, are available out of the box in Raster API you can use. So as long as you enable Raster functions when you publish the server, publish image service, which by default is enabled, you can use it in JavaScript API. On server side, when you publish a service, you can actually chain multiple Raster functions and create a Raster function template, make it available to JavaScript developers. Now let's see some demonstrations of that. So this application accesses the Esri Landsat service. It's the Landsat 8 service is maintained by Esri. It pulls the latest data available from Landsat 8 sensors. So my last check a few days ago is this single service contains roughly 500,000 scenes. If each scene is roughly 1.5 gigabyte data, is roughly like 700 some terabyte of data. So it's a mosaic data set, which means it contains a lot of different images, overlapping images, a particular area. I can actually, let me turn off the debugger for now. I can actually configure different rule, instruct the server to mosaic it, to inspect the same area. This, by the way, is in UAE. This is Dubai in 2000, in 2006. I can also ask the server to perform some processing, such as perform some change detection. In this case, we define the processing algorithm, the functions, the parameters. We send this to server, let the server to process it. Server will process it and return the processed image, typically in rendered format like JPEG, PNG, and can display on client side. So let me just show you how this is done for this dynamic processing. So the first thing I do is image difference. So I use the arithmetic function. I provide two rasters in this area. These are captured at different time. So the result from this arithmetic function is going to be the input to the thresholding function. The threshold function provides a way to do automatic binary thresholding. So if there's significant change in an area, after you do a difference, the image histogram will show a bimodal distribution. Then we will be able to automatically detect the change. So the output from this threshold function is simply a yes or no answer, change or no change. It's 1 or 0. Because there are 6 bands, I would like to see if a particular area is changed in all 6 bands. I will mark it really changed, otherwise it's no change. Then finally, I use a color map function to highlight these real changes in red color and set everything else to transparent. Then I call the Raster layer, image service layer, to set a rendering rule. Then send this to server. The server will process it and deliver the result back. There are a lot of other example applications that leverage server-side processing. I would like to show you another case here. It's the GeoPlanner application that's available today. ArcGIS Online, I think it's also available through ArcGIS portal as well. So one good feature in this application is it has a modeler that allows you to pick different image services. Actually, there's different data set. These are thematic data, categorical data usually. Some of them are continuous, like elevation or aspect. So what you can do here is to pick this different data set as input and perform some modeling, like define the weight of each raster, and then save it. Which this app is doing is actually creating a raster function chain, then send it to server. So if I make a tiny pan, I'll be able to see the real request. So it's a pretty long raster function. So it's so long that exceeded the default GET request limit. So it has JS API flip to post request. So image server is pretty powerful, and it has all these well-defined algorithms available to you to leverage in JS API. So the demonstration I did in this application actually used the new Raster layer. So from the equivalency perspective, I said that we designed the Raster layer to really replace the existing ArcGIS image service layer if you can use modern browsers. So essentially, you just see, when I construct the Raster layer, I just say I use the JPEG or PNG or JPEG PNG format. This format are the default for ArcGIS image service layer. Then you essentially get the same thing. You can do all kinds of operations that the server support. But the Raster layer also provides extra benefit. So in addition to this JPEG PNG rendered format, you can request raw data from a server, then do some client-side pixel manipulation, then put the rendered RGB data back to the canvas. So one important feature that Esri offers is the lurk compression, is a limited error raster compression. It's invented by Esri. We actually have a patent for that, but we recently open sourced it on GitHub. Over there, we provide a standard C API, encoding and decoding, and a standalone JS API for decoding lurk data. So lurk and many other formats are used in ArcGIS JS API to provide the raster decoding so that the Raster layer we can perform some client-side manipulation. This is done through a Raster API. So the Raster class has a read method which you can provide the image service parameters. It will handle the XHR request and decoding for you. Or if you have the array buffer data, you can decode directly as well. The decoded data structure is in pixel block. You have a width, height, pixel type, and the pixels, the mask data, as well as statistics. So pretty much the only thing we need to do to perform a client-side processing is to implement a function. This function performs pixel filtering. The input to this function is pixel data, which has the pixels as well, the pixel block, as well as the extent that corresponds to this pixel block. Then you loop through columns, rows, pixels, then do some mathematical or any other type of operations. One use pattern of this is after your processing, you draw the render data on the map. Another pattern of using this raster data is since you have the raw data, you can actually run some aggregation, statistics, and present the data using some charts, etc. So let's see some example of this. So the first example I'm going to show you is actually the National Land Cover Service available on Sample Server 6. So this is the image service. It serves one band data. It's categorical data. It has only one band, but it has a nice color map and the related land cover categories for each color, for each pixel value as well. So I'm using a Raster layer here to request the one band data from a server and request the color map from a server, then render it on the client side. Then since I have the raw data on client side, I can do some interesting things, such as I can hover over my mouse on the map and dynamically draw statistics in 5 miles radius to see the land cover composition. So it can be very responsive because there's really no round trip to server. This is performed on client side. And it's capable of doing this because we have the raw data available on client side. So the pixel filter after this is pretty simple. Oops, it's right here. So on every map move, I listen to the mouse event. So I get the circle, then I see which row it starts, which row it finishes. Then we will run some statistics, do some simple geometry, and go through the rows and columns. Then I get all the data aggregated into this pixel value count object, which is the pixel values and the count of the corresponding pixels. Then pass this to the charting pipeline. So the result is here. So the next example I'm going to show you is actually a little bit more interesting. It's since we are doing this Raster layer using the canvas element, we have some benefit that comes along with the canvas element, which is widely talked about. So in JavaScript, you can actually leverage GPU for computing and rendering. This is done by writing the shaders directly. Well, we don't really have a CUDA here that you can write easily, but it's not really that difficult. You write the vertex shaders and the pixel shaders to really perform some complex processing, such as hair shade. Hair shade requires the 3x3 neighboring computation. You need to get the slope and aspect, then composite them together to really draw the hair shade. So if you really need to do this on server side, for every change, you need to send the request to server. So it won't be very responsive. But if you do it on client side, you can actually make this change really dynamic. So the code behind this is actually one algorithm implemented in shaders. So vertex shader and the fragment shader, we usually work, in most cases, you can use any one of them to do computation, but most people choose to use fragment shader to implement the image algorithms. So this algorithm itself is well documented in ArcGIS help. You can just search how slope works, how aspect works, etc. There are some So some kind of JavaScript work you need to do here in addition to shaders. Essentially, you need to provide a way to hook up your parameters and pass it down to WebGL using these standard uniforms or texture, etc. So this example, let me see, get my shaders. Yeah. So this Raster layer in the initialization, so different than other shaders, I need to explicitly instruct the layer C to turn off the draw mode because I'm going to use WebGL to process and draw. So my draw type is WebGL, experimental WebGL. Essentially, it's the canvas context type. So in this PixelFilter WebGL, I did all the plumbing. Compile, get the shaders and compile the shaders to get the picture raster program. And I fetch the texture, fetch the floating point data as an image texture. So I pass down all the like altitude, azimuth, etc. as uniforms. So every change, I provide the updated parameters and ask the WebGL to draw. So by doing this, I can get a very responsive client-side app. So let's go back to the slides. So WCS layer, I would like to talk a little bit about OGC since we covered the Raster layer. So you can enable web coverage service on any image service as long as you have a valid special reference, which is the case in most cases. So for the first time, we have this WCS layer available in JavaScript API. It's currently still tagged beta, but the feature is pretty much mature. We tested it extensively using ArcGIS image service WCS servers and also some third-party servers. So this WCS layer took a similar approach but follows OGC protocol to gather data in TIFF format client side. And by doing so, we can leverage the similar pixel filters that we do with the Raster layer. So let's see a quick demo for that. So in this demo, you can see this is the Arctic service that's provided as part of the part of the ArcGIS content. So in addition to Landsat world elevation, we have actually a dedicated service for Arctic elevation. It's released last year. So this app provides access through image services. But since it also has WCS enabled, we can actually access the same service, same Arctic service through WCS. And because we can do client-side pixel filtering, so the interactive hair shading algorithm we implemented for the Raster layer can be leveraged here as well. It's the same thing. Let me just show you the request. Whenever I point the map, the layer follows the WCS protocol to make a get coverage request and provide the version, the the bounding box, the format is GeoTIFF, and the OGC standard for spiral reference, which they use CRS, using the EPSC code, etc. So the Raster compression algorithm, I would like to show you a GitHub repo actually. So for WCS, we can't really use Lurk because it's open, but it's not really part of the OGC protocol, but it's part of the image service. So on GitHub, under the Esri organization, there is Lurk repo. You can actually search for some standalone examples provided by the community, such as this nice demo. It's actually using the leaflet API and using this standalone Lurk decoder to work with ArcGIS Online elevation services. It's very performing. And if you look at the code, it's pretty simple. The core code for this layer is just like 50-some lines. It's pretty easy to use. So there's another type of layer is ArcGIS image service vector layer. It also uses Lurk data, but requests data from a server but visualize it on the client side. So this type of data usually like from wind force or ocean current. It's two-band data represent u and v, which is the velocity in both x and y directions, or magnitude and direction. This type of layer is pretty easy to visualize them in the vector format instead of raster format. So we have a well-defined symbologies like arrows, wind barbs, or built for wind scheme or ocean current schemes. So one important feature for this type of data is they are really multidimensional. So on the Raster layer or ArcGIS image service vector layer, you can call the get multidimensional info method, which will fetch all the available variables and dimensions from a server. Then on the client side, once you have this information, you can actually construct a dimensional definition to specify which variable you want to use, which dimension you want to use, and which slice you want to visualize or process. So let me show you a quick example of this. So this example shows is a service available on ArcGIS public server. It's on public sample server 6. It's time enabled, multidimensional. So you can request to visualize the wind data in different time. And because there are many different time slices, you can leverage the identify or get sample API to fetch all the data from a server and visualize them using some frequency chart, etc. So we actually have a follow-up session after this session to just talk about this type of data, scientific data in general. Thanks. Back to you, Naila.
Thanks, Wenxue. So you guys learned about what all we have in JavaScript API 3x. I want to talk a little bit about 4x. 4x is the next generation, easy-to-use JS API, which has support for 2D and 3D. In 3x, we learned that we have the ArcGIS image service layer, and we also have the raster layer. In 4x, we have the imagery layer, which is very similar to raster layer in functionality. It renders image data, it requests data as pixels, and since you have pixels on the client side, you have all the client-side processing capabilities that Wenxue spoke about, all the pixel filters, and it also supports server-side processing. It supports different formats. It supports pop-ups, query. You can save your layer in a web map. You can load your layer from a web map. It also supports the multidimensional API that Wenxue spoke about. And the most importantly, it supports 2D and 3D visualization. So for the imagery layer, it's pretty simple. The constructor, it's similar to the 3x. The bare minimum thing you need is the URL. And then you create your map. You create your map and you specify your base map and your layers. Now, one map is usually, it's like a container that you can use for storing and managing your layers. The one thing different that we have in 4x is the concept of a view. A view is responsible for rendering your data. You can have two different types of views, map view, which is for 2D, and scene view, which is for 3D. So let's take a look at one sample that we have over here. This is a sea temperature service that I've loaded in a 2D map. And what I'm visualizing over here is that it's a multidimensional service, but I'm seeing only a slice of sea temperature at a particular depth at a particular time. And if we look at the code, we can see that we are loading the map view, the imagery layer, which is really important over here, the raster function, the dimensional definition, and these classes are similar to the 3x. We've tried to keep the layer API similar, even though you would, in general, there are big differences in 4x and 3x. But the imagery layer API, we've tried to use the similar objects so that it's easier for you guys to move from 3x to 4x. So we have the mosaic rule where you can define the slice that you want to view or how you want the images to be mosaiced. So if we take a look at it, this is the URL, this is the service that I want to display. I create my map with the base map, pretty simple, straightforward. Since it's a 2D application, I create a map view and I define the container, the div. I define the map. Are you guys able to view it, or should I increase the font? Maybe this might be better. I define the map, the zoom scale. These are pretty similar to 3x. And this is where I define that slice that I was talking about, the slice that I want to view. So I define a dimensional definition object and say that I want water temperature, and I want it at a particular depth, which is at the sea surface. And now I also want to define a specific date. I want to look at this slice at this particular time. So I define the variable as being the water temperature and the dimension as time and the dimension value. And once I have this, I can set it as part of my mosaic rule object. And so far this has been, this is pretty similar to how you do it in 3x also. Now, since my service has a default stretch applied to it, in this case, I don't want that stretch to happen. So I create a raster function and I say, don't do anything. And now what I want to do is that the return of that service is a single band service, but I want to see it as a multi-band service where I can have red for warmer temperatures and blue for colder temperatures. So I create my own pixel filter. I have the pixel data. I find the min and max values. And what I'm doing is I'm just manipulating the single band and converting it into multi-band over here. So this is how we construct our different bands, and we combine those bands and set it as part of our pixel block. So we are just manipulating our pixel block, converting it from a single band to a multi-band or 3-band pixel block. And now I create my imagery layer. So I define the URL that I had up there. I define the raster function that where I say that I don't want the stretch to happen. I define my pixel filter, which is converting single band to 3 bands. And I define the mosaic rule where it's defining a slice that I want to visualize. And now what I'm doing is I'm adding it to the map, and this is my view. So I want to say that once is added, the layer is added to the view, and the view is ready for rendering, do this part. And this part is actually just displaying a message telling the user, okay, you can click and get a sea temperature value. But the idea is that you have methods like when layer view, meaning that when the view is ready with the layer, the view is created and it's ready to render it, then do something. So you saw the output of this, right? I just showed you. Now let's say I want to change this and I want to do the same thing but in 3D. So all I need to do is, the most important thing, I need to change my view, because for 3D we have scene view, for 2D we have the map view. And let's refresh it and take a look at this. Oops, I zoomed in too fast. So with just one thing changed in my application, I can now view it in 3D. So that's how powerful and easy to use your 4x API is. Now going back, we have the documentation resources which you can refer to when you're working with 3x and 4x. And now I want to just take a few minutes to talk about Web App Builder. Most of you might know that Web App Builder comes with a very easy to use interface. It's really useful if you're not a developer, but you still want to create custom application. We have a lot of widgets available, but it's also useful for developers because you can create an application and then download it and then modify it and build and add your own functionality to it. So it really reduces a lot of the initial time that you need to create a generic application. It gives you all that within few clicks, within few minutes, you can have your application, and now you can modify it and add more things that you like as a developer. Now, if you go into Web App Builder, you would see that there are some generic widgets, just like in map viewer. You have the layer list, you have the legend control, query, attribute table, pop-ups, all that are supported for imagery layers as well. But we have two important imagery specific widgets that you would get. Image measurement, which lets you measure heights of buildings, and oblique viewer, which lets you view your oblique images in an image coordinate system, in its own coordinate system. And that is really important for oblique imagery because it helps avoid all the different distortions that you would see if you would display oblique images in a map projection. And since we have time, maybe I can show you quickly what the oblique viewer looks like. So I've used Web App Builder. I created this application. I won't be able to go through the creation process because we're running out of time. But once I have the application ready, this is my imagery. And I've added this widget, which is the oblique viewer widget. And all this comes out of the box. So when you go to Web App Builder, you can pick the widgets. And in that, you would see an oblique viewer. You just need to click it and add it to your application. Save your application, run it. And when you run it, you will see this button over here. When you click, it opens up a window. And what it's doing now is it's displaying this imagery that you have over here. But it's displaying it in image coordinate system, in the coordinate system of the image. And when I zoom in, I can see for this building, I have imagery available in different directions. I can view it towards north, I can view it east, south, west. But the idea is it lets you view your images in different directions in the image coordinate system, in its own native coordinate system. And I can even now perform measurements, and it'll tell you what's the height of the building. So it's a pretty useful widget. Now, in addition to the two core widgets that I spoke about, we also have some custom imagery widgets. They are not available out of the box, but we have a GitHub repo which has all the detailed information on how you can get these widgets, how you can set them up. And it's pretty simple. You just, you go there, you download the source code, you unzip the files, and then there is a well-defined documentation that tells you what you need to run to set it up. And to give you an idea about what those widgets are, I'm going to show you Lancet Explorer. So this is the GitHub site that I was talking about where you can go and download. It gives you, there are some live applications that you can go through just to get an idea whether these widgets are useful for your work or not. And one such application that we've created using these widgets is Lancet Explorer. So if you go in Lancet Explorer, you would see it has this choose rendering option where it shows you all the processing templates that you have published with your service. And this is a Lancet service which we keep on updating almost every other day, I think. It's fairly recent, and it is really powerful in terms of what you can do with it. It has all these products that you can visualize. So I'm looking at color infrared, but I can look at agriculture or any other product over here. What I want to do, the other, I think, really cool widget that we have is the time selector widget. So you all must have worked with time slider. Time slider can sometimes not be very user-friendly, especially for data where where you have holes, like it's not available for the whole time slice. Whereas this time filter is really useful because each tick over here is actually will give you an image. So right now I'm looking at 25th of January 2017, and I like this, and I'm going to mark it as, as one of my secondary layers. And now I can go back in time and go to a different date, and I can see the imagery for that date. And the other cool thing that I can do is they have a change detection widget where I can click, and now I can actually perform a difference between the 2017 image and I think the other one was 2014, I forgot. But basically those two different dates, and it shows me the difference right here. And there you can see the difference in using the different indexes. Water was one of them, but you can even see the changes in vegetation. So it has some pretty useful controls. It also has a swipe control, a mask control where you can mask different, it shows you the histogram and you can define the values that you want to mask. And the other, I think, really cool widget that is available is the Save Top Layer. It lets you save the output of, let's say, change detection or masking as an item in ArcGIS Online in your My Contents. So you have the results saved, which is, I think, pretty useful at times. So moving forward, there are lots of enhancements that are coming in. We are pretty excited about this, especially I think in terms of symbology, because we've heard that we've added the ability to set color ramps, but that's not enough. Sometimes people want to specify unique value renderer, or they want to classify their imagery. So that's what we are working on. We're working on a full-blown symbology editor where, just like desktop applications, you will be able to change symbology, define the renderers that you want to use. The other important thing for Portal for ArcGIS that we want to add is the ability to apply or run analysis using any custom RFT. So today I showed you guys those 11, 12 tools that we had, and those are the higher workflows that we envision our users using it. But there are a lot of users that have their own processing and they want to run raster analysis using their processing. So we want to let you guys do that. And in future, you would be able to, if you have your own processing defined, you would be able to select that in Map Viewer and run raster analysis against it. The other important thing we want is, I don't know how many of you use the desktop product, but we have the raster function editor where you can actually visualize your whole processing, the whole chain, the different functions that are there. You can build your own chains. That whole experience, we want to bring that experience on the web. We want to bring it in Map Viewer. So moving forward, that's where we're heading to. For the JavaScript API, we have this functionality of working with pixel filters right now, but we want to have a clear separation of raster functions and the renderers. And we want to have a well-defined APIs. We want to give you guys out-of-the-box functions that you can run on the client side. So imagine not going to the server for doing, let's say, extract bands or different band combinations, applying that, just doing everything on the client side. So that's one area where we feel that it's going to be really powerful, and it'll help you guys build very responsive UIs and applications using that. So in 4X, in terms of imagery layer, we are pretty good in functionality wise, but we do lag the vector layer that Wenxue showed you, which works with the multidimensional data set, and the WCS layer. So those are the different layers that will come in for 4X. Just as a summary, so we went through the capabilities in ArcGIS Online. In Portal for ArcGIS, we saw how you can work with raster analytics and the tools that are available for you, and also the addition of image collection, how you can zip up your images and quickly upload and publish a small collection of imagery. In ArcGIS API for JavaScript, Wenxue told you about the different types of layers in 3X and the layer that we have in 4X. We also touched upon how you can set these pixel filters on the client side and perform your own processing. We discussed a little bit about the Raster API and the different decoders like Lurk that are available for you guys, the multidimensional API, and also the 2D and the 3D support in 4X. And the web app builder experience. So that's all we have for today. I hope this session was useful for you guys. We would really appreciate your feedback. Please let us know if this was useful or if it wasn't, if we missed out on anything, or if there's something in future that you would like to know. But your feedback is important. So thank you so much for coming today, and please let us know what you think about the session. Thanks. And if you guys have any questions, yes.
The widgets that you mentioned, those are web app builder widgets, right?
Right.
Do any of them have that slider functionality?
There is one which is the swipe. This one, I believe.
The selector is available. Yeah. Time selector.
Yeah.
The time selector, right?
Like
The select time.
Which one?
This one, right? Is it this one?
Yeah, something like that, like a
Yeah.
slider like that, where
Yeah.
you can kind of select which.
Oh,
Is that's for transparency as you set it up now? Is that right?
This one is for time.
For time, okay.
Yes.
Okay, and is that widget there? That's one of the web app builder?
Yes.
it's on GitHub.
It's
Yeah.
on GitHub.
It's on GitHub. Yes. Yes. All these widgets, all these things that you see over here, they are all available over there.
Awesome, thank you.
Yes.
The LERC, is that a lossless compression?
Good question. LERC, limited error raster compression. From the name, you know there is error inside, right? So whether it's lossy or lossless depends on the criteria you define. There is a term called, if you go to GitHub repo, different places probably use this term slightly different. If you go to the GitHub repo, you can see there's something called max Z error. Oh, sorry. Yeah, thanks. Yeah, if you go to the Esri GitHub repo, you could see the methodology it used to compress raster. It actually compares, try to preserve a certain degree of accuracy. The parameter to control that is called max Z error. Essentially, you define the precision of the pixel values. For instance, elevation data, right? You could have or temperature data. You could have a lot of floating point values, but the sensors that you put in the field are only capable of capture certain level of precisions, like two decimal places. Then you can set the max Z error to 0.001. That is how you control it. In this case, it is lossy. But for integer data, if you set this to 0.5, because integer type of data, 8-bit or 16-bit, is incremental is by 1, it actually is always lossless in that case. It's lossless compression, but still achieve a pretty good compression ratio, depends on the data. Let's say the classifier data like land cover, this cases, is the compression ratio is very good, just like PNG and others, this length encoding, etc. Internally, it has a lot use different strategies, like the relative encoding the relative difference using the Huffman in certain cases or lookup table. So it does support lossless compression for integer data. For floating point data, typically we specify max Z error, so you can control the accuracy. But if you see max Z error is 0, then you have a lossless compression. Yeah. Thanks. Yeah, go ahead.
When migrating raster functions from the 3x raster layer to the 4x imagery layer, have you found that you've been able to just like copy and paste the same syntax, or have there been some growing pains where you've had to adjust the syntax to work with the 4x imagery layer?
Right. The syntax is exactly the same for raster functions. So if you've defined them, they should work in both places.
So all the pixel filters, client-side manipulation that you wrote, just copy-paste. It does work.
Yeah. Anything else you guys would like to know? Okay. Well,
Cool.
thank you.
Right on time. Thanks.
Thanks.